My name is Enas Yousef. Polymer capillary tubes with inner diameter less than 25 micron are used in open tubular system as separation conducts. The separation performance depends on the exact diameter of the capillary tube. So it's really important to determine the tube inner diameter, which can be done microscopically on specific cross section, but for uniformity along the capillary tube cannot be measured this way since it's destructive methods only for semi-transparent capillary. Photomicrographic measurements along the capillary tubes can be done, but the curved surface of the capillary and the mismatch of the refractive index between the polymer and the luminant cannot content induce the error of the measurement from the optical distortion. Thus, several methods were studied to measure the inner diameter. So, first one, measuring the internal volume of giving length of capillary, electrical resistance of liquid filling the tube. Third one is using Poiseuille's equation by measuring the pressure drop and flow rate. First, we determine the inner diameter of high density polyethylene capillary tube using the photogrammetric measurement of its cross section from several cuts. Since the high density polyethylene capillary tube is transparent, transfers for photogrammetric measurements along the tubes can be done. Different measurement of the inner diameter was observed using different solvents inside these tubes: air, water, and fluorescent dye. Their measurements were observed. There's difference between them due to the refractive index mismatch. Then the inner diameter was determined and measured using the internal volume of the capillary tube using different approach, gravimetric measurement, where it's based on the weight difference between empty tube and filled tube with liquids such as water and mercury. And the second, then the radius was measured using this equation. The second approach is the absorbance and fluorescence or conductance of the solution that exploded from a tube. Then the concentration of this solution were measured using calibration curve. Then the radius was measured using this equation. The electrical resistance, where the resistance between the two ends of the tube that's filled with mercury was measured using multimeter, and the radius was measured using this equation. The last method is using Poiseuille's equation, where we determine the pressure drop of a flow rate. Then we apply this equation. Then we have the last one, which is determine the delivered volume for a specific pressure. Then we apply it to this equation. Result table 1 represents the inner diameter measurement of the high density polyethylene capillary tube for different cuts. Figure 5 represents the inner diameter measurement of 100 centimeter high density polyethylene capillary filled with different media. As for table 2 and 3 represent the measurement, the inner diameter measurement based on the gravimetric method using water and mercury respectively. Figure 6 it represents the measurement of the poured volume using solution delivered from different length of high density polyethylene tube versus calculated inner diameter. As for figure 7, represents the calculated pour ID based on the resistance of mercury liquid through different lengths of high density polyethylene tube and fused silica. Figure 7, 8, and 9 represent the inner diameter calculated based on Poiseuille's equation of the 3 high density polyethylene tube with 100 centimeter length through pressure drop and flow rate measurements. Thank you.